In this video, I'm going to talk about permutations and combinations, but first I want to talk about something called the fundamental counting principle. Fundamental counting principle. All right, so if event A has m possible outcomes, or m possible ways that it could happen, and event B has n number of possible outcomes, then there are m times n ways to do both things, or to have both outcomes occur. So, for example, maybe you have 5 t-shirts and 4 pairs of pants in your suitcase. So that means there are 5 times 4, or 20 total combinations. Combinations of shirts and pants. All right. Now, this is kind of what leads us into permutations and combinations. But the permutations and combinations formulas, they use something that is called a factorial. So what I want now is to introduce a key idea, which is a factorial. Now, a factorial, we use this exclamation mark symbol. So n factorial is literally n factorial, how we say that. Oops. All right. So what a factorial is, it's the product of a whole number, oops, of a whole number multiplied by every whole number from itself down to 1. So, some examples of factorials. 1 factorial is just 1, 1 times 1. 2 factorial, that is 2 times 1, or 2. 3 factorial is that whole number 3 times 2, bullets, times 1. And 3 times 2 is 6, times 1 is 6. 4 factorial, that is 4 times 3 times 2 times 1, which really, I mean, this is 3 factorial. You're just multiplying it now by 4. Oops, sorry, not 12, 24. 4 times 3 is 12, times 2 is 24. And the last one I'm going to write out is 5 factorial. Now 5 factorial is 5 times 4 times 3 times 2 times 1. And 5 times 4 is 20, times 3 is 60, times 2 is 120. And we could keep going, right? So what are permutations and what are combinations? We're going to start with permutations. And permutations are all of the possible ways that a group of objects or items can be arranged. And the thing that is specific to permutations is that these are arranged in an order, in some particular order. So if maybe I'm lining up my students in a line, there is a set order to that, a first, a second, a third, a fourth, a fifth person in line. So the notation for this, oftentimes, if we are going to choose K items, or sometimes this is R items, out of or from N total options in an order, we write this as the subscript N and then the capital P and then the lowercase k. And again, sometimes instead of K, an R is used. But the formula for this is N factorial divided by N minus K factorial. Whatever that difference is, the factorial of that number. So let's write out what these things mean. N, again, is your total number of items. Total number of items. And K represents the amount that you are going to select. K number of items to select. And sometimes this is the same number of items that you have to begin with, but sometimes it is a smaller amount. Now, what are combinations? Combinations are all of the possible ways that a group of items or objects, group of items, can be arranged or selected with no order. So permutations, there is an order, order matters. Combinations, the order does not matter. Now, if we are going to choose, again, K items from N options, our formula for combinations, N with an uppercase C and then R, the combination, ooh, not K, not R, K. Choosing K items out of N total options, the formula for this is N factorial over N minus K factorial times K factorial. So another way you might see this is still N factorial in the numerator, and then in the denominator, K factorial times whatever that difference is, N minus K factorial of that difference. So again, we have the same variables as defined before. We have N total options. So N is our number of options. Oh, I don't like the way the purple shows up here. So circle it. N total options. And K is the amount that you are selecting. See how the blue shows up with the yellow. All right. So let's look at some examples using all this, because this kind of means nothing until you see it in action. So I have my examples down here. First example we are going to look at. Out of 12 contestants in a talent show, only those in first, second, and third place will win a prize. How many different ways can the 12 contestants be ranked in these positions? So what I notice is these are going to be ranked, meaning the order matters. right? We have a first, a second, and a third. So I want to use permutation. I'm going to use the formula for a permutation since the order matters. And from above, right, my permutation formula. If I have n total objects, and I'm going to select k amount, I have n factorial over n minus k factorial. So what is n and what is k? Well, we have 12 total contestants, so n is 12 in total. And then the amount that we are selecting, we are ranking them in first, second, and third place. So k is 3. So filling in the values to find the permutation, the total number of ways we can rank these contestants. We have 12 contestants that we are trying to rank in first, second, and third. So 3 total positions that we're interested in. So this is going to be the total number of contestants, n factorial, so 12 factorial over the difference, 12, our total number of contestants, minus the amount we're ranking them in, 3, 12 minus 3 factorial. And we can actually evaluate what this means, right? So 12 factorial, let's just leave that in the numerator for now. Over 12 minus 3, well, 12 minus 3 is 9 factorial. So I have 12 factorial over 9 factorial. And when you get comfortable with factorials, you'll recognize the pattern that happens here, but we can write out all of the numbers that are being multiplied. So 12 factorial, that is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And then, of course, we're going to multiply in the times 1. I don't really need to write that. And then the denominator, we have 9 factorial. So that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. So you'll notice a lot of numbers repeat in the numerator and the denominator. So all of those are going to cancel. So the 9s, the 8s, the 7s, the 6s, the 5s, the 4s, the 3s, and the 2s, they're all going to cancel each other out. So the total number of ways that we can rank these contestants is really just 12 times 11 times 10 number of ways, which if you multiply that, that means there are 1,320 ways. All right, we're going to do one more example. So this is example 2. In an election, voters are asked to select 3 city commissioners out of 8 total candidates. How many different ways can this be done? So we're just selecting 3 out of 8, and the order here doesn't matter. Order does not matter, because if it did, they would say so. Since the order doesn't matter, I'm going to use the combination formula. So if I want to grab that from above here, let's see. If I'm going to choose k items from n options, that is n factorial n factorial over, I like to put the k first, the k factorial, and then the difference. I don't know, that's just me though. N minus k factorial. It really doesn't make that big of a difference. But now let's identify what is n and what is k. So n, the total number of options, we have 8 total candidates, and the voters are going to select 3. So k is 3. So let's fill in all of the pieces. It's a combination. We have n is 8 total items, and we are going to select 3. So I'm going to substitute in all the values here. So I'm going to have the number of total candidates, 8, oops, wrong color here, 8 factorial divided by the number we're going to select, k factorial, times that difference factorial. So the difference, n minus k, or 8 minus 3. K is 3. 8 minus 3 factorial. Now, I really can evaluate most of this by hand. You can put it in a calculator, but you don't have to. So 8 factorial is still going to be in the numerator. And then in the denominator, I have 3 factorial times 8 minus 3 is 5. So 3 factorial times 5 factorial. Now I cannot multiply that together. What's really going to happen here is I'm going to write out what is 8 factorial, what is 3 factorial, what is 5 factorial. So 8 factorial, that's 8 times 3 times 2. Oh, wait, what? I was looking at the, the denominator down there, getting ahead of myself. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2, and then times 1. And then I'm going to have the 3 factorial. So that's just 3 times 2 times 1. And then the 5 factorial, which is 5 times 4 times 3 times 2. So really the 5 factorial part, that's going to cancel out, right? We have the 5, 4, the 3, and the 2 in both the numerator and the denominator. So I'm really left with 8 times 7 times 6 divided by 3 times 2. And the lovely thing is 3 times 2 is 6. So this 3 times 2 will cancel with the 6 in the numerator, leaving us with 8 times 7. So if there are 8 total candidates and I'm just going to select 3 in any position, there are 8 times 7 or 56 total ways this can be done. Please let me know what questions you have, and I look forward to seeing you soon.